Okay, let's have a look at covalent compounds. Covalent compounds, unlike ionic compounds, only contain nonmetals, and the nonmetals join together to form molecules. So carbon dioxide containing nonmetals only is an example of a covalent compound. Now if we remember back, each nonmetal atom within that compound wants to gain a full outer shell. In other words, they want 8 electrons in the outer shell. Unfortunately, unlike ionic compounds, none of the electrons have been donated to the nonmetal, so there must be another mechanism for forming a covalent bond. And it turns out that the covalent atoms, or the non-metal atoms, can actually share electrons to effectively get this 8 electrons in the outer shell. So we can say a covalent bond is formed when atoms share electrons with each other to satisfy this octet rule, or 8 electrons in the outer shell. Let's have a look at some examples, and one of the examples that I have is actually an exception to this octet rule. So we've got our simplest atom, hydrogen. Now hydrogen can form covalent bonds with hydrogen. They have 1 electron each. Instead of donating an electron one way and accepting it one way, they share electrons. So if we draw our structures here with our 1 electron outside our nucleus, and then we join these two together, effectively each hydrogen atom has 2 electrons because they've shared those electrons. So let's look at something a bit more complex. We've got hydrogen once again, and we have a fluorine atom. Hydrogen contains 1 electron, fluorine contains 2 on the inner shell and 7 on the outer shell to give us 9 electrons in total. As we said before, the hydrogen is an exception to the octet rule, but the fluorine wants 8 electrons in the outer shell, so it wants to grab one. Now it could grab it from the hydrogen, but the hydrogen wants an extra electron as well. So the way to satisfy this to form a bond is that they're going to share these 2 electrons, as we've drawn here. So effectively the fluorine has 8 electrons, and the hydrogen also has and the hydrogen has 2 electrons. So that covalent bond is formed when these 2 atoms share these 2 electrons. Now we can draw our model for our bonding in another way. We can use what's called a dot structure, or Lewis dot structure. And this shows the valence electrons only. So I've got a hydrogen atom with 1 electron. I've got a chlorine atom with 7 valence electrons. These will share the 2 electrons to satisfy the octet rule for the chlorine and to give us 2 electrons for the hydrogen. So effectively the chlorine has 8 electrons and the hydrogen has 2 electrons, and this bond forms between the 2. We can represent this bond here, the 2 electrons, as a line between the 2 atoms. And then obviously we can shorten this down to give us our formula for hydrogen chloride, or hydrochloric acid. Let's look at something slightly more complex. We have a molecule of methane, Ch4. Our carbon has an electron structure of 2 in the first shell, 4 in the second. So it's the 4 in the second that we're concerned with, because we're only going to show the valence electrons. So our carbon will be surrounded by the 4 electrons. Now we know that it wants to get 8 electrons, so it's going to have to share these 4 with another 4 from another source. Hydrogen has 1 electron, so we represent it as 1, and we've got 4 lots of that. So if we draw a molecule of methane, Ch4, we've got carbon sharing 4 electrons with 4 different hydrogens. So it effectively has 8 electrons, which satisfies our octet rule. And our hydrogens effectively have 2 electrons, each one of them does, because they've shared 4 electrons, each one has shared 1 electron with the carbon. So this would be our Lewis dot structure for our methane molecule. And then obviously we can simplify that by saying between each carbon and hydrogen we have a bond. So we've got a carbon surrounded by 4 hydrogens. Now we can also look at water. Once again, hydrogen has 1 electron. Oxygen has 2 in the first shell, 6 in the second shell. So we can represent that as oxygen surrounded by 6 electrons, or 6 valence electrons. We need 2 lots of hydrogen, because we're going to share electrons through these 2 single electrons here. So we form 2 bonds, one with each hydrogen. So the hydrogen has effectively 2 electrons, this hydrogen has 2 electrons, and the oxygen effectively has 8 electrons to satisfy the octet rule. So simplifying this, we would have oxygen with 1 bond to each hydrogen. Now we can get multiple bonds through non-metal atoms as well. So single bonds are formed when we have 1 pair of electrons. So each time we have a pair of electrons, we form 1 bond. However, we can also get double bonds, and this is where we have 4 electrons shared between 2 atoms. So if we take oxygen bonding to oxygen as an example, we can share these 2 electrons and we can share these 2 electrons. So we get 4 electrons being shared between the 2 oxygen atoms, and we call this a double bond. And it's represented as 2 lines instead of a single line as we've represented it up here. Finally, we can get a triple bond where 6 electrons are shared between 2 atoms. So nitrogen has 5 valence electrons. With this nitrogen as well, we can share these 2, we can share these 2, and we can share these 2. And this effectively gives us 6 shared electrons. As we said before, if we've got 6 shared electrons, we form a triple bond, and we represent this as N with 3 lines between it representing those 3 bonds.